Good morning. In this video, we're going to be looking at Math 3, Unit 4, Assignment 4.4. And this assignment revisits the idea of fractional exponents. From the overview, you know that students did learn about fractional exponents during Math 2, but it was just a brief exposure. They transferred back and forth between exponent form and radical form. They had some exposure to work with radicals, but they really by no means are experts at fractional exponents. And so now we have a chance to help deepen their understanding about the concept and build a little bit more skill with the concept. And so let me just tell you a little bit about what's going on in the book. These first two problems here give you an opportunity to use exponent rules and develop understanding of why a fractional exponent would be the same as a radical expression. So here, if using exponent rules, we could add these exponents and get -3 to the 1 power, which they realize is -3. We could also think of when we multiply something by itself 3 times, that's the same as if we cube it. Oh, pardon me, let me just back that up. It's the same as if we cube it. And we know that this does end up equaling -3 to the first, or -3, and that gives us kind of a feeling that what is in here must be the cube root. Since when we cube it, we get -3, what's in here must be the cube root of -3. This problem gives another chance to experience that definition and the why of how that would work out to a 4th root if it's 1/4. The next part, 3, 4, and 5, all bring up opportunities to see some things students usually miss. And so if you don't use the book as notes, these are good things to make sure you include in your notes. A negative fractional exponent, students often accidentally flip the fraction instead of doing the reciprocal of the thing that is actually being raised to the negative power. So if we think of this as two separate things, long version would be to actually think of it as t to the -1, or I'm sorry, t to the 3/4. Sorry, let's try that again. Need my coffee this morning. T to the 3/4 and then to the -1. We can first flip that and then write it in radical form, the 4th root of t cubed. Now, it doesn't say to simplify these expressions, so you might accept this as just transferring back and forth between exponent form and radical form. But I think this rationalizing is one of the hardest pieces in the chapter if it's something other than a square root. And so you might want to take the opportunity to have the students also rationalize that for practice. There's a couple other spots that practice rationalizing. Number 10, I believe, wherever number 10 is a chance for rationalizing. Number 13 is a chance for rationalizing. Number 20 is a chance for rationalizing. If you look at your teacher's edition answers, you'll find that those answers are rationalized, and that would be good for the kids because they have a hard time with that. Here, another thing to include is decimal exponents, because they have that a couple times in the assignment. And students just need to have a good understanding of decimal, that 1.2 is the same as 12/10 or 6/5. And that could be written using radicals as the 5th root of y to the 6th. And then simplifying that completely, we'd want to take as many y's out as we can. So if we group 5 y's together, that could be 1 y on the outside, and there would be 1 left inside. No absolute value is needed because this is an odd root, and so we don't need to worry about signs coming out. And so those two things are things you'll want to include in your discussion: negative fractional exponents, decimal exponents. And then this piece is here just to clarify a point in the definition. If you look back a page at the definition in your book, it'll say that the definition of a rational exponent applies to real numbers. And so we know that this is not going to represent a real number here, a negative underneath a square root. And so it gives you an opportunity to reteach a little bit about imaginary. Since our students are so light on their imaginary understanding, it's not a bad thing to do. If I was going to do this, I would say before you can use any radical rules, you need to get so you have a real part. So you can make this square root of negative 1 times square root of 10. That square root of negative 1 is going to be an I. And now this, all our rational exponent things can apply to. So this could be 10 to the 1/2 because 10 is a real number. And so this could be 10 to the 1/2 I. If we wanted that answer. You might choose to skip this problem. This doesn't come up again in later assignments during the chapter or on the assessment, but it is just an opportunity to bring up I in a year where our students don't have very much experience. So it's your choice whether or not you want to bring that up, but either address it or skip it intentionally. Don't accidentally stumble upon it. Just know that it's there. After you've hit those 3 spots, you'll just find lots more tricky practice. Right here, 9 and 10 would be really good to have practice to do something like this, because this shows that if you have a 4th root and a square root, you can't multiply those. Those are not the same root, but the fractional exponents do allow you to be able to combine those, because when you put it in fraction exponent form, you can then get a common denominator, and that means you can put them under the same root. I might have gone from this step to this step, but some people would do that by factoring out the 1/4 power first, and then having that left, and then simplifying from there. You do need to keep going from there. But so this shows that when radical form is not handy, fractional exponent form allows us an extra tool, getting a common denominator that we don't have when we're in radical form. So that's why fractional exponents is sometimes a handy thing to do. All right, so continuing on through this assignment, I just want to point out one that you may want to assign for homework, or you may want to save for a discussion the next day. This problem is meant to help students kind of sort the knowledge that they have in their head and make sense of that so they can remember it and use it at appropriate times. So this problem itself is very simple. 4 to the 1/2 times 4 to the 1/2. They suggest doing it 3 different ways. So here's my work for doing it 3 different ways. Let me just slide that over for you. So 4 to the 1/2 times 4 to the 1/2 using exponent rules, I would add those and get 4 to the 2/2, or 4 to the 1, which is just 4. Second way that I can do that is simplify each term separately and multiply afterwards. So I can think, well, 4 to the 1/2 is square root of 4, and square root of 4 is 2. I can do that for each term separately and then multiply. I got the same answer both times. And a third way is to change to radical form, work in radicals, and simplify at the end. And so I can change them each to square root of 4. I can go ahead and multiply because they have the same index to be square root of 16, and then I can break that down to be 4. So work with exponent rules, simplify separately, or work with radicals. All 3 of those are tools that students have. Now, if you just look at this problem, students are likely to say, well, why don't I just do this? This seems the easiest. Why would I mess with either of these other things, or whichever happens to be their favorite? And so you might want to push that by giving them another set of problems. Let me show you a possible set you could give them. If I have 4 to the 1/7 times 4 to the 6/7, that might not be so easy to do separately. I don't know the 7th root of 4, but I do know that I have a common denominator there, and I can just add those exponents and get to the 7/7, or 4 to the 1st. And so this would be much easier to do with exponent rules. This one, I can't use exponent rules because I don't have a common base, and if I change to radicals, they're not going to be the same index. And so getting a common denominator is one possibility, but it does seem easier since these are so easy to work out, to work them separately. The cube root of 27 is 3, the square root of 25 is 5, 3 times 5 is 15. That seems easier in this case. And in this last case, I can't use exponent rules because I don't have matching bases, but if I do change to radicals, I do have matching roots, and so I can go ahead and multiply those together. 2 times 7 is the cube root of 14. And so each one of those methods has a place where it's really convenient and helpful. And really being master of all those methods means you can always pick the easiest way. You don't have to be stuck with a really difficult way. Challenge them to do this by getting common denominators and then breaking back down to get 15. This is much more difficult that way. It's really fortunate that we have multiple ways, because then you can choose wisely and pick the easiest way. So problems like this really help our students kind of codify what they have learned, sort it, make sense, store it so they'll be able to use it again. So I encourage you maybe to think about putting this up as a warm-up or as a homework assignment and addressing again with more challenging problems. Okay, good luck with this. This is one of the assignments that our students seem to have more trouble on. So take the time on that. Have students check answers together when they come back. See if they can correct each other's mistakes. That's a good way to build understanding. Good luck and have a great day.